Thank you once again, Acasio. Anybody else who wants to do a super chat, feel free. Feel free. Feel free. Feel free. Feel free to super chat. Okay. So now let me talk about the topic of the day and give you some value out of this live stream. Okay. So I named this live stream Modern Era of Physics because we're going to be discussing the theory of everything, or if there is a theory of everything, question mark, question mark, question mark, as we sometimes do, of course. Remember, all of that discussion about superstring theory was really because superstring theory is motivated by being a candidate for the theory of everything. Some theory that can subsume all of physics and explain all of physics in a broader, more liked way. Because there were parts of physics, some big, extraordinary, up and coming, extraordinarily different, insightful, and sort of breakthrough sorts of things that happened in the 20th century, which also did not see eye to eye. So there's an eye here and there's an eye here, and they did not see eye to eye. Okay. So these were namely, of course, general relativity on the one side and quantum mechanics on the other side. These two sides of physics were not seeing eye to eye, were not quite unified by something broader, bigger, better, sort of this mother cruise ship, if you will, that can kind of subsume all of these little boats underneath it and let everybody sail and let everybody have a rhyme and a reason and a method to the madness. So even though these theories, even though these pieces of work, not even theories, because a lot of these things have also been proven out, they've been shown with experiment, they've had tremendous experimental success in each of these fields, but yes, they do have certain drawbacks, certain little flaws, if you will, or certain limitations. Both are not totally correct. And they don't see eye to eye. The people who generally work on these things, on the one side, general relativity or classical physics, if you will, classical as in it's not Newtonian mechanics, it is a correction to Newtonian mechanics to give us a theory for gravitation, but it is also not quantum mechanics. It is not the theory or the physics of the very, very small. So the physics of the very, very big, general relativity, and the physics of the very, very small, quantum mechanics on the two sides don't agree. But there were both gifts given to us in the modern era of physics. So if you're ever taking a class called modern physics in your undergrad or grad or wherever, even if you're not a physics major, you might come across this class.